Hi, this is Dr. John Bergduff. In this video, I'm going to show you a very simple rational inequality and show you how you can solve it if you know some basic techniques about graphing. Now, there are about 1 million ways that people show solving rational inequalities. This is just one, but it has the advantage, if you already know how to graph a simple rational function, of requiring very little machinery. So let me show you what I'm talking about. This is the rational inequality that I want to solve. And the first thing I want to do is solve the underlying rational equation. By underlying rational equation, I simply mean, what if we took the less than or equal to and changed it to an equal to? So we make an equation out of it. 2 over x plus 3 is equal to 1. Now this is a fairly simple equation to solve, especially if you use the principle of balance that says that you can take an equation and multiply both sides by the same expression. If I happen to choose x plus 3 as the expression that I want to multiply by, x plus 3, which is the denominator of that fraction, would cause the fraction to completely go away on the left and give you a very simple equation to solve indeed. Distributing the 1 across like this, we would simply have 2 is equal to x plus 3, and subtract 3 from both sides, x is equal to negative 1. Okay, that's wonderful, but that's solving an equation when I had asked for an inequality. So how is that going to help? We'll show that this is a small piece of solving the equation, the inequality. So let's look at this. This is again the inequality that we wanted to solve. We're going to get a 0 on one side of that inequality, like this, and then consider the graph of the corresponding rational function. Look at the left side of that inequality and call that expression f of x. If you know a little bit about graphing, you can say, oh, I recognize what that looks like. This is going to resemble the graph of y equal 1 over x, which is a simple graph that we know. If we look at just a couple well-known points, plugging in a negative 1 into this equation would give me negative 1. You can't plug in a 0. That gives you something undefined. But plugging in a 1 would give you a 1. This general simple shape is the graph of y equal 1 over x. And we'll remember that it is this shape approaching the x and y axes as vertical and horizontal asymptotes. The extra little expressions that are added into the function just adjust that graph or transform that graph in some simple ways. The x plus 3 in the denominator shifts the graph 3 units left, 3 units left. The negative 1 on the end shifts the graph 1 unit down. And the 2 in the numerator causes a vertical stretch by a factor of 2. If we look at that, we can indeed get what the graph would look like. Now, this doesn't imply that you already know a little bit about graphing rational functions. When you cause a shift in a rational function, the entire asymptote structure shifts with you. So if this graph shifts 3 units to the left, the vertical axis, which is usually the y-axis, will also shift 3 units left and will look like this. So this is the new vertical asymptote. The shift of 1 unit down is going to have an effect on the horizontal asymptote. It shifts 1 unit down. And whereas in the basic function y equal 1 over x, this point is 1 unit to the right and 1 unit up from the origin, because of the vertical stretch and essentially the moving of the origin to a new place, we'll start where the two asymptotes cross and move from there 1 unit to the right and 2 units up to create the vertical stretch. And we will also look at the graph to the left of that, whereas in the original function y equal 1 over x, we have a point 1 unit to the left and 1 unit down from the origin. With the new origin, we would start where these two asymptotes cross and move 1 unit to the left and 2 units down. The shape of the graph will be very, very similar. It will go like this, approaching this vertical asymptote and coming down, crossing the x-axis somewhere. Where is it going to cross the x-axis? Well, that will cross the x-axis when y is equal to 0, and you know what that is? That is the solution of the underlying rational equation. So this -1 is going to turn out to be the x-intercept of the graph. And that tells me that I can put a definite point right here. The graph will go through here, approach this horizontal asymptote, looking a little bit like this. And then similarly on the other side, the graph would look like this. So if you know a little bit about graphing rational functions, the graph is easy to draw. How does that help you with solving the inequality, though? How does this come together? Well, let's look at it this way. So if this was the inequality we were originally given, and the first thing we did was we got a 0 on one side and then defined a function, what we're then really asking, if this is my f of x, we're really asking for which values of x is f of x less than or equal to 0. So if I can recreate the graph here real quickly, remember that we will have a vertical asymptote here at -3, shifted 3 units to the left, horizontal asymptote here at -1, shifted 1 unit down. We had a point right here and an x-intercept right here. This portion of the graph looks like this. And then we also had a point right here, and this portion of the graph looked like this. The inequality is equivalent to asking for what values of x is f of x less than or equal to 0. That's really asking where is the graph below the x-axis. And if you're looking at the values of x where that happens, you can see that the graph is below the x-axis from -infinity to -3. We have to exclude -3 because that's where the vertical asymptote is. Then the graph is above the axis. So this, what I've represented so far is this branch. Then the graph goes above the axis for a while, but it goes back below the axis beginning right here and continuing on. So union -1 to infinity. Again, there's many ways to solve rational inequalities, but here's a way to do it if the function is fairly simple and you happen to know how to graph it.